This is Paul Steciuk. I'm with Northeast Power Systems, NEPSI. Today we're going to talk about key interlock systems. More specifically, key interlock systems and how they're utilized on metal enclosed capacitor banks and harmonic filter banks. NEPSI's systems, nearly 95% of them utilize key interlock systems. It's almost an industry standard that all metal enclosed cap banks utilize a key interlock system. So it's important to understand how they operate and what they do. First, the reason you install a key interlock system on a metal enclosed cap bank or a harmonic filter bank is to dictate a sequence of operation. You're dictating a sequence of operation with key interlocks. You're also looking to dictate a safe entry into the enclosure. More specifically, you're making sure that the system is grounded, that the system is disconnected, and that it's safe to go in. Once you've done that with the key interlock system, you're allowed to go into the enclosure. Before doing that though, before getting into how it works, let's talk about the types of locks you have. So down here on the floor, I have several different types of locks. And this lock here is called a base mounted lock, and it's because of the way it's mounted on the device that you're looking to key interlock. Typically that's used on a disconnect switch, like a group operated disconnect switch. This is a door lock, detachable door lock. And what's interesting about this is that when I turn it, this comes off. So oftentimes this is put on the door and this is put on the door jamb. There's two detents here, actually 4 detents here, that push into the lock here. These push and basically what we're looking to do is to guarantee that the door is shut, and then in that case we can close the door and lock it closed. The barrel is extended. So until the door is properly shut and perfectly aligned, and that's key, it has to be perfectly aligned, you can extend the lock and remove the key. And that helps to dictate that we know that the door is shut and that the door now the key can be removed. Another type of lock here, this is a heavy duty lock. So these are brass, this is stainless steel. So in the North Country or in harsh environments, it's very common that you use a stainless steel lock like this. And there you can see the key is way different, significantly different than this type of lock. So these types of locks, you do not expect to have the key freeze up. And again, when the barrel is retracted, the cylinder of the lock is retracted, the key can't be pulled. Incidentally, that's the way most of these locks work. When the key is extended, the cylinder is extended, you can remove the key. When you retract it, you can't remove the key. So the key is only removable when the barrel is extended. Now, you can buy a key interlock that's the opposite, and it's very common that that also gets done. This is a contact maker. We have a key interlock, and we have a contact maker, and we're making contacts. And this is an electrical contact maker. So we oftentimes use this in our control panel to open and close vacuum switches within our equipment. Sometimes we might use it to communicate with an upstream feeder breaker to block close, or to provide a permissive to allow a breaker to be closed. So contact makers are very common in key interlock schemes. So that's how that works. And then finally, we have a face mounted lock here. It's face mounted because it mounts on the face like this. And again, when the barrel is extended, the key is removable. In most key interlock systems, that's the way it works. All right, so another type of key interlock system is a key transfer block, and that's what I show here, a key transfer block. In this type of system, usually you insert just one key. In this case, it would typically come from the control panel. You would insert that into the lock. You can see that all the other keys rotate. These keys all carry the same interchange, same key number. And oftentimes what we can do is we can remove these keys, and we can take all these keys to all the different doors within the enclosure and open each and every door. They're all keyed identical. And we do this so that the interlock scheme is simpler. One key will drop a bunch of other keys out of the lock, and it will allow us to open maybe 6, 7, 8 doors at once. So it's another way to simplify the key interlock system. Another type of lock is a solenoid operated key interlock, and we use that in our control panel here. And what it is it requires that we have power to be able to turn the key off. So in this case, what we typically do is we have a 5-minute timer. We have a timing release here, And once the capacitor bank has been de-energized for 5 minutes, in other words, we let the capacitors discharge for a period of 5 minutes, we will get illuminated light here that would allow us to then rotate the key and pull the key out. So the key is trapped until a 5-minute time period has elapsed from the time that I turn these to the off position. And that's the way this solenoid operated lock works. Just to show you the back side of this, you can see on the back side there's a solenoid here. We have the electrical power to the solenoid to allow it to operate, and then we have some contacts down here that we're utilizing. So we can fool the system by pushing up on the solenoid and extending the lock back and forth. So it's something that's good to know if you're a maintenance person and you need to get the key out in less than 5 minutes. You can open the swing panel, push up the solenoid with the hand, and pull the key out here. Another thing that's important to talk about is that each lock has a serial number associated with it, and it has a key interchange associated with it. So this one's A1, and it's got a serial number. Generally speaking, if I have an A1 key, the key interchange is A1, I can only go to another lock with A1, and this key will only work with a lock that's labeled A1. So we can dictate a sequence of operation because we can change from one lock to the next lock, the key interchange, and dictate a sequence of operation. And that's exactly what we do with metal closed cap banks and filter banks, is we dictate a sequence of operation. Okay, so now let's talk about the sequence of operation, how this KIRK key interlock scheme works. So here in front of me is a metal closed cap bank, and it's a 3-stage cap bank. This is the control compartment. In this piece of equipment, we have the control compartment at the end. This compartment is not key interlocked. The reason it's not key interlocked is because it's a low voltage compartment. We are allowing entry into this compartment. So I open the door, and the first thing I want to talk about is that inside every NEPSI metal closed cap bank and filter bank, we have a key interlock scheme shown. We show a diagram of how the key interlock scheme works. We also have a 3-line diagram. So on the 3-line diagram, you can see the disconnecting devices, the ground switches, and other various aspects of this piece of equipment, so you understand what you might be doing as you're going through the sequence of operation. The key interlock scheme, the drawing that we show here, it's important that you understand how to read those. Okay, so let's take a look at the actual KIRK key interlock drawing. This is what we ship with every piece of equipment. Is what's on the control compartment door. So the first thing you should note is that in the top left corner, we always have a legend. Key to this legend, and most important, is these 2 squares. The first square has a vertical line in it that indicates that a key is present in the lock. The other one has an open circle with no vertical line that indicates that there is no key in that lock. So when you look at a key interlock drawing, you will note that we have these little square boxes everywhere in the drawing. Some with the vertical lines indicating a key is present, others with no key present. So let's start at looking at the drawing. The first thing we note is that we would start at the control panel. Typically, you see that there's a red dashed line that goes into the capacitor bank. That red dashed line is indicated here in the legend, and it indicates that the vacuum switch wiring. So this is a contact maker. And basically what happens is the A1 key, which is present here, we would remove that. And incidentally, all key interlock drawings provided by NEPSI show the drawings in the energized condition. Okay, the energized condition. So that's why the A1 key is present here. So we would have this, we would turn the capacitor banks off, remove this A1 key, the A1 key that's present in this location, and we would walk that down according to the dashed lines here to the first isolation switch. We would then operate the isolation switch. We show that there's an interlock bar between the isolation switch and the ground switch, and that's basically indicating that you cannot close the ground switch while the isolation switch is in the closed position. That would make sense. You also note that there's an A2 key present in the ground switch. Okay, so once the A1 key is inserted into the isolation switch, you unlock the isolation switch, you throw the isolation switch to the open position, And in so doing, the interlock bar is freed up, the ground switch is able to be thrown. You throw that ground switch and you remove the A2 key. When you remove that A2 key, it extends the cylinder into the cam of the ground switch operator and locks that ground switch in a closed position. And you can proceed with the A2 key around the enclosure up to the top here. And you can see that it goes to another ground switch. Again, an open circle indicating no lock, no key is present in that lock. Put the key into the lock, unlock it. That allows you to operate this ground switch. We close the ground switch, which effectively grounds the capacitors associated with this stage, and we take that key out. And taking the key out, you're locking the ground switch in the closed position. And we proceed through to the next lock in a daisy chain format. And this is really the essence of key interlock systems, is that they're daisy chain. We're dictating a sequence of operation. If you just step back and think about what we're doing here, we forced the stages off, we freed up this key interlock in this solenoid operator, which then allowed for the removal of the key. Once we removed the key, we locked the bank in the open position. In other words, the vacuum switches were not open. We're allowing for the operation of a non-load break isolation switch. Incidentally, all isolation switches associated with capacitor banks are non-load break. They're not tested for capacitor switching. So the removal of the A1 key locks these switches in the open position, and it makes it safe to actually operate this isolation switch. So once we open all the ground switches, we're coming back around here. Okay, you will note that we take the A5 key out, and that opens the first door. We take the A5 key from here, locking that ground switch in the closed position. We remove the A5 key, walk it to the A5 lock on door 6. We insert it, we turn it, and in so doing, when we turn A5, it releases key A6, unlocks door 6, and then we proceed to the next door, door 5. And we daisy loop these. You can see that we just continue around. A8, walk around A8, insert it into door 3, unlock it, remove A9, and we continue on. We have all the doors open. We've dictated that sequence of operation. Interesting thing to note here, and I will note it further in the presentation, is that the incoming door allows access to the isolation switch. And if you see here, we have the upstream customer breaker here feeding power cables into the isolation switch. So the bottom side of that isolation switch is energized. So it would not make sense to allow somebody into this compartment because it could be energized. We open the isolation switch, we allowed access into these areas here. We note with the blue dashed line that that's an isolated compartment, but access to this compartment would not make sense unless those cables were de-energized. And that's exactly what this B1 lock is here. You note that it indicates a different set of key interlocks. In this case, the blue line represents the B locks. And with the B locks, what we are looking to do is dictate that the customer breaker is locked open in a racked out position. That lock is typically down in the rails of the breaker compartment. You would rack out the breaker, and then you would lock it in a racked out position. It would then release that B1 key, which would guarantee that that breaker remains racked out, because in releasing the B1 key, you've effectively locked it in the racked out position. You take that B1 key and you go to an interior door behind the first door here that then allows you to open that door and gain access to these components. So that is how you read a key interlock drawing. We always keep these drawings on our enclosure door because it can be quite complicated. There's also a set of notes always included with our key interlock system. It's also important, very important, that you read those notes. Okay, now that we've gone through the key interlock scheme and how it works, let's go through it in sequence. So the system is sitting here energized. It's typically the way it would be when you walked up to the equipment to get into it or to maintain it. You would go up to the system and the lights would be on, indicating that various stages are on, and you want to or wish to get into the enclosure. So what you would do first is you would look to turn off the stages, turn off all the stages. Do not open the feeder breaker to turn off the capacitor bank first. You always want to use internal switching devices to switch off the bank. So we put these in the off position. As we're putting these into the off position, you want to verify that the switches in fact went off. There is a chance that a switch is defective and it will go off, and you need to know that. So you want to make sure that everything is going off before you proceed with your key interlock scheme. You could check the metering also to make sure that the current went from a value to 0. So you have the ability to check metering. You could go upstream to the feeder breaker or to the disconnect that feeds this equipment and also check for current there. It should be 0 amps. So once we have 0 amps and we know that we've turned the system off, the key interlock scheme would dictate that we go to the air disconnect switch. So let's go around to the air disconnect switch. So this is the A1 key. This is the air disconnect switch. Up on top of here, we have the ground switch. The first thing we do, we note that this is locked. Put the A1 key in here, rotate it, and I throw the switch. Air disconnect switch through. It's important at this point that you check through the window, make sure that the air disconnect switch is open. You can see the blades. There are ways where the switch can become inoperable, and you could throw this handle that would free this key that would allow you to actually throw the handle, which would then allow you to throw the ground switch without actually having the disconnect open. So it's important to look through the window, make sure that the disconnect has open. If you have a chain drive operator, the chain can break. That's one way. The other way is the contacts, the main contacts of the disconnect switch can get stuck closed. Even though you threw the handle, the disconnect can be stuck closed. So you want to make sure by looking through the window that the 3 are open. So always specify windows in the incoming compartment. Once the disconnect is open, there's a interlocking bar that exists between the ground switch and the air disconnect switch that allows now this handle to be operated. And to throw this, you want to go through fast. You want to push through fast, just like I did there. And that will then allow us to remove the A2 key. The A2 key locks the ground switch in the closed position. So it's allowing us to proceed to the next step. Nobody can open the ground switch while I proceed to the next step. So the A2 key, according to the key interlock scheme, goes to the first ground switch. So follow me around to the ground switch. So I'm at the first ground switch. This key is labeled A2. And I can verify here that we're dealing with an A2 key here also, A2 lock. I unlock the ground switch and I throw the ground switch here. A fast motion is always better. Do not go slow with it, go fast with it. That will free up the A3 key. Sometimes I have to move the handle here to get the key to remove. That locks this ground switch into closed position. A3 goes to the next ground switch. So you can see what I'm doing here. I'm throwing ground switches on each and every stage to allow entry into the enclosure. What am I doing? I'm grounding the capacitors in this case. Not all cap banks get ground switches like this. Some do, some do not. So you have to look at the key interlock scheme to see what you got, to see what you. In my hand, the A5 key goes to the enclosure doors. We've effectively grounded all the stages. I go to the first door, a note here, door is locked. I unlock it. As I unlock this key, you can see the top key automatically turns. I'll show you again. As I turn the A5 key, the A6 key gets released. We're retracting a barrel in here, which frees up the door handle to allow me to open it. I take the A6 key and I proceed to the next door. I can repeat the process each and every time. I rotate the A6 key, A7 gets released. I go to the A7 lock, insert the A7 key, rotate it, release the A8 key. Okay, so I have the A8 key in my hand. I'm going to the next set of doors on the opposite side of the enclosure. I insert the A8 key into the A8 lock, rotate it, remove the A9 key. This is open now. We can repeat this process for all the doors. Unlocking all the doors, which allows entry into the entire piece of equipment. And I release the A11 key. Now this is a special door. This is the incoming air disconnect switch. Remember, this is where the feeder cable is feeding power to this piece of equipment is located. When you open this door, I want you to take note that we have included a second barrier. All of NEPSI's banks get a second barrier. This is a second barrier to entry into a possibly live compartment. We put an additional key interlock here to make sure you cannot get into this compartment until I open an air disconnect switch or racked out a breaker upstream. So it's important to realize that this compartment can be energized and that you need a separate key interlock scheme between this disconnector, this compartment, the incoming cable compartment, and an upstream feeder breaker or an upstream disconnect switch. So typically to get into this compartment requires that I go to an upstream feeder breaker or an upstream disconnect switch and I open it. It's important to realize that the upstream device needs to be a device that has a visible break. To open a breaker but not to rack it out is not a correct interlock scheme. It must be a visible break, something that creates a gap between energized parts. So we can picture if it was a breaker at the moment. We would open the breaker, we would open the door, and we would rack out the breaker. At the point that we racked out the breaker, there would be a key interlock down in the rail of the breaker, and we would lock that breaker in a racked out position. We would release a key. That key would go to this compartment. We could unlock it, and we would have access to this compartment. And that is the complete interlock scheme. That's how you get into the enclosure. So before actually entering into an enclosure, even with all the ground switches that we've had, it's important that you tap each capacitor with a ground stick. We run a ground bar along the complete length of this enclosure. Okay, you would attach a ground to here with a hot stick, and from the hot stick you would have another lead that would then connect to the capacitors to discharge the capacitors. We would do that for each and every capacitor. And in this way you've made sure that the capacitors are discharged, that they're not holding any trapped charge, and it's safe to handle those capacitors. Okay, so once maintenance is completed, we're going to close up the system. The first thing you should always note before closing up the system is look into the enclosure, make sure all the tools have been removed. Make sure your ground straps have been removed. Everything that does not belong in the enclosure should be removed. Once you have everything removed, close the doors. I note that this is a double door. If you have double doors, you need to bolt the doors shut. It's important to bolt the doors shut. Okay? We would close and we reverse the process. And you would do that for all compartments. This key here would go to the upstream feeder breaker or upstream disconnect to unlock it, to re-energize the system. You, of course, would want to wait to do this. This would be the last item to do. So we reverse the process, locking everything up. Again, sometimes I have to move the handle just a little bit to free up the key. Now we go to the ground switches. Again, A5 key. This ground switch right now is in the closed position. We're looking to open it. And again, nice swift motion here. And then we're in. It's locked here. You want to look through the window, make sure that the ground switch is in fact open. Now these are direct drive handles, so we wouldn't expect an issue there, but you should always check. Just safety first. Locked, closed, making sure again that the ground switch is in fact open. So this is the A2 key. This goes back to the ground switch. So we've locked all the doors. Everything's locked. We'll go back to the ground switch here. It's on top. Again, this is locked. Everything's ready to go. Unlock it. And again, swift motion. Open it. Want to make sure. Yep, ground switch is open. And I close the ground air disconnect switch here. And I remove the key. This is the A1 key. This goes in the control panel. This is what energizes the system. Before doing that, we had the key for the feeder breaker or the air disconnect switch that was upstream. You would go there, you would close that air disconnect switch or that feeder breaker and put power to the equipment. Once that is done, take the A1 key and you bring it around to the control compartment. You go back into the control compartment. First thing you'd want to do is make sure that all the control power breakers are on. Why? Because we want to put power onto the control panel to put the system in operation. Make sure everything boots up properly, and then close the control panel door, put the A1 key into the interlock, put the on-off auto switches into the auto position. That will allow the stages to be energized in automatic mode, put the system in operation. So when we ship the equipment, we always ship with the extra keys in the enclosure. We do that because we want to allow you to get into the enclosure easily when it is received at your factory. So all spare keys are put in the equipment. So the spare keys have a tag on it saying remove this key before operation. So before you put it back into operation, you have to remove all the extra keys within the system. Remove all the keys with tags. And actually before you put it into a energized state the first time, you should go through the key interlock system once to make sure that it follows the diagram that you provided. And in particular, pay attention to ground switches and disconnect switches. Make sure the disconnect switch is open before the ground switch is closed. Things like that. You want to look for things that are out of sequence, things that we're trying to prevent. You want to make sure that they are in fact follow the key interlock system. So check to make sure that the key interlock system is doing what it was intended to do. Okay, so that seems like a lot of keys, a lot of steps, but the point of it is safety. We're looking to dictate a sequence of operation, and we're looking to dictate safety. We're looking to make sure that you don't open air disconnect switch under load. We're looking to make sure you don't get into the equipment while it's energized. We're making sure that you don't go into the equipment before the trap charge and the capacitors has discharged into the system. So it seems complex, but if you follow the diagram and you go through it once or twice, it will be quite easy to follow. And that's the point of the key interlock scheme, is to dictate a sequence of operation and to dictate safety. Thank you for watching.